plumbing, HVAC design on projects. Some quick housekeeping things if you hadn't had to find them yet. There's a bathroom back there through the hallway, and then there's 2 bathrooms to the left of the bar area. They are all like single occupancy bathrooms, so if it's closed, give it a knock. Kind of want to keep this as informal as possible. So if you've got any thoughts or questions as I'm talking, feel free to shout them out or interrupt me. I won't be offended in any way. I did want to thank Ann also. She did great amount of work putting the flyers together and help getting the word out for this event. Had a pretty good turnout here. KLH is kind of excited and dedicated to helping Ann kind of see where this group can go within the next year, see if we can kind of keep the momentum going, keep the kind of the numbers coming up, spread the word more. So yeah, so we'll.
I'll just say that if you can sign up for the Facebook and Twitter feeds, just share them. The more people that know about it, the more interest we'll have, and the likelihood it will continue everything. So don't just like or something, but actually share it and get it out to your contacts.
Yeah, definitely. Thanks.
And there's also Wednesday and Greer. Pretty good that.
So before we get into the actual presentation, I just wanted to go over some general stuff about KLH Engineers. If you guys are not familiar with us, haven't heard of us before, we are, traditionally an MEP firm, mechanical, electrical, plumbing design for construction projects. We also have technology and lighting services that we can offer. Also recently been getting into building scanning with BLK360 camera, so that's another service that we can offer. 5 offices total. You can see the locations there. Fort Thomas, Kentucky is our headquarters, if you will. Company size, we're about 105 employees encompassing all offices. Key thing that will kind of come to light in this presentation, some of the tools and stuff I'm going to show you that we developed. Of those 105 employees, at this point we do have a dozen plus software programmers that are strictly doing programming, helping us create tools within Revit that can help our efficiencies. We do work across multiple studios. You can see there: healthcare, education, commercial, civic, and retail. So we pretty much touch the major markets. Been in business for 63 years. I just checked, our project numbers. We were just around, 21,300 projects completed over that 63 years. So, on the Columbus office specifically, we kind of just celebrated our 10-year anniversary within the city. We had a little get together last Thursday, kind of help celebrate that. We work on projects that cover all those market segments that I kind of talked about in the previous slide. And, the projects that we get here in Columbus are staffed by our local team. So you'll be working with, local people if you're working with KLH Columbus. So, presentation agenda, what we're going to be going over today. The topic was better BIM models. The first thing we're going to get into is, what is the problem that better BIM model is addressing. So we're going to, hit on inefficiency in the construction industry real quick, like a real high level overview, and then we're going to dig into, these different points here about what we can be doing as an industry. All of us, engineer consultants, architects, etc., what we can be doing to help make our models better for a better overall construction process. So the waste discussion is kind of split up into, two buckets, waste and design and waste and construction. Waste and design is something that you may, not think of initially, but in general, when you look at, drawing packages for construction jobs today, they're still really incomplete, so to speak. The full design isn't really being shown in plan. They're kind of, created for permit. You hear the term design for permit, which is, kind of let's get this design done, let's get permitted so we can get into construction. But you can find that, rushing that process, not creating, a well-constructed model can lead to headaches, and change orders, and RFIs once you start getting into the actual construction of the building. And that last point there, designs are created to be destroyed. So this is something that I can, kind of relate to on a personal level. When I first started working here and I was doing designs, it was a little while before what I designed actually started going into construction. But sitting in, coordination meetings, and things like that, I quickly found that a lot of times contractors are completely recreating the BIM models on their end, and basically, essentially trashing, what the engineers have put together, just because, they didn't have the confidence in it. After looking at it, they could see that what was really drawn wouldn't work, so they essentially need to start over. So you can think about, how much time just on the contractor side they may have as their in-house engineer kind of redesigning work that already been done. It's pretty wasteful. The waste and construction side of it, there's 8 points here or so. But look at the construction industry, we're, around $1.3 trillion total. I've got 30% value there estimated as waste. Depending on who you talk to or whatever, presentations you may see being given by different people, that value can, range. But essentially, 30% on 1.3 trillion, you're looking at almost $400 billion of avoidable cost, just through improving the process from start design to construction that could be, kind of worked out. So, if you think about that, we all have clients, what was the budget of their last job? It's not something that you bring up to them, at a project kickoff, whatever, the owner tells you all that. We have a $100 million budget, and you go, oh, well, let me stop you there. Just so you know, $30 million of that is, a big waste. It's not really a conversation that's happening. So what is this waste coming from? So, there's some points listed here, but, you look at inventory or excess products and materials. I mean, I can't tell you, how many times you go to a construction site and you see the on-site dumpsters there, and they're full of like new material that's never been used, whether it's, cutoffs, etc. Just, basically something that, pre-planning could probably help with that. Motion, you can think about, how much time on a given day any employee spends just like walking back and forth from the spot that they're working to where the material may be. They could be working on, the third floor, maybe the elevator isn't even in yet, and all their materials are, downstairs in what will be the lobby, and they're walking back and forth all day. You can quickly see how that time will add up. Probably even relate that to, each of your personal lives if you're working on, a home improvement project. I know, like, no matter how simple the task is, if I'm working in my upstairs bathroom, I'm probably running back to the garage, like, 15 times for various things that I can get. So, first topic that we've got here to essentially, help make this better live model, and that's moving data into the model. I'm kind of saying we need to attack two main categories here, and that's specifications and generic detailing. If you can think about a given drawing package, a full drawing package, just how thick a given spec book could be, and how much information is contained within those specifications that's nowhere on the drawings. You can kind of quickly see how I mentioned our design for schematic design earlier. That's kind of what that's getting at. I can tell you from personal experience, when I'm working on projects and I get an RFI or something like that from the contractor, they're asking me something. Maybe it's something that I missed putting on the plan, and they say, "Hey, do I need this?" I go check my plan. I see that maybe it's backflow preventer or something like that. I see that I missed it, and I know they're right. I know they need it. So the next thing I'll do is I'll go to the specification section, and I'll try and find somewhere in there where we say that they needed backflow preventer. So you can imagine how frustrating that is, for the contractor, that they didn't find some random, word in 1,000-page spec book. So that's the specifications category of it. Generic detailing, which I kind of relate this maybe to somewhat of a carryover from CAD, and I'm still seeing a lot in models, drawing packages that I see, and that's essentially detailing of key areas of the building, like mechanical rooms, electrical rooms, things like that, where the high dollar stuff lives. Detailing of that's still being done with generic detailing, as I've coined it, but it's this is constructed of detail lines, model lines. It's not specific to the room that it's actually trying to detail. This may not be how it actually gets installed at all, because the layout of the room can't accommodate it. So this kind of detailing, in my view, is basically, I might be communicating to the contractor, I need these valves here, etc. But I'm pretty much saying to them, I want you to actually figure out yourself how you're going to fit it in there. The other kind of issue with generic detailing is it's a missed opportunity to use Revit families, which can contain a lot of useful data, parameters that they can have, can be almost endless. And we'll get into a little bit about how the power of Revit truly is data that lives in the model. So what are the solutions, to these two problems, essentially? And two initiatives that got started at KLH as a way to address this is initially just get rid of them. So the two goals, the first one here is eliminating that generic detailing. So how do we do that? So you can see, that kind of booster pump bladder tank example from the previous page. This is what we show. So what do we really need to be doing? You can see that this is really what we want installed and what we really should be modeling in order to give the contractor what they need to install. So this is kind of the same setup. It's essentially fully modeled. It has all the valves, all the families, all the piping modeled, and essentially what replaces the generic detailing is, it could be a section view, like what's shown here, that's, fully detailed, outlining what everything is. You can see that it's even, got some dimensions on it, that really gives the contractor a good idea of, what my design intent was as an engineer. Nice metric view. Adding this, to the plan to maybe work in conjunction with this is also a great way to help show your overall design intent and how things are all fitting together. So that second goal that we started at KLH was essentially to eliminate specifications as well. And we quickly learned when we set out to try and tackle this is that the first thing we needed to do was basically look at our specs and comb through them and just eliminate redundant, useless information. We were kind of surprised to see, how many times the same information may be repeated over and over again in specifications. Sometimes even contradicting themselves, which just adds confusion to the contractor. So this was kind of our initial result. Here you can see all the disciplines listed, and I mean these are some pretty serious values here. From HVAC alone, we eliminated 781 pages from the specification. 76 from fire protection, 61 from plumbing, 249 from electric, and 161 from technology. So once we kind of got that redundant information out of the specifications, we kind of needed to keep going. So we needed to think about how we're going to keep kind of chipping away at our specifications. And essentially, as an example here, the way to do that is you essentially start showing information that's in the specifications on the plans themselves. So you can take piping, for example. This is an excerpt from our domestic water piping specification, where we outline the piping materials that are allowed to be used for domestic water piping. The contractor's looking at a plan, and we have sanitary vent lines, domestic water, fire protection. We have all this stuff on plan. For the contractor just to know what material they can use for those pipes, they would have to go to 7 or 8 different spec sections. Imagine how long that would take to come through all that. So the solution in this case is we're going to start putting that critical information into the pipe that we're actually drafting within Revit. So you think about the material, the ASTM numbers that it needs to apply to, which system it's at. Yeah.
How are you addressing submittals on that information now? Because usually it's a specification that drives the requirement. Or are you saying if you meet what's on the drawings, the submittal is not necessary?
We would still go through a submittal process, but I guess essentially, rather than me as an engineer coming through all our specs for a project that I did 6 months ago, I'd be going to the drawings, which are technically part of the contract documents, comparing against that.
So you're not
How would
eliminating
where
the
do you
specs.
where would you state your requirement that you need a specification for that? Or need a submittal for your water pipe or for your domestic pipe?
So we might still have a plumbing submittals spec section. I'm not saying that we have necessarily eliminated specs altogether at this point. So yeah, good point. They would need to go to whatever number for plumbing is, see what the submittal process is.
Question for you.
Yeah.
I've been a contractor, subcontractor, and I know for me, I'm planning off of the drawing. That's what I'm looking at. Specs, I look at, but there are disconnects between the drawings and the specifications sometimes. So if I come up and say, hey, what should I do here? Here's two conflicting things. You go off the specs, or usually in my case, what's more expensive, you know? Say, well,
Right,
I
yeah.
did off of the drawings. Yeah, the specs are part of it, but there's always what we call no CMs. That's just like
Oh, yeah.
generic notes hidden in the specifications. So, and what I've seen too is a lot of times engineers will copy and paste specs. They use the same ones. It's a lot of work for you to go through them, just like it is for me.
Oh, yeah.
So you just put everything on there, you know? So what you're telling me is you're condensing it, and for every job you're going through and making sure your specs match up. Like you're kind of shaking the edge of sketch with how it's typically done. Right?
Yeah. So like for this pipe example, for instance, you know, we might not, you know, at some point we may be able, you know, to eliminate domestic water piping spec, but you know, for right now, we're just not telling you in the spec what material you can use, because we're going to put it all on a schedule or a general note on it. Right. Yeah, that could be another option. Yeah. So for this example, you know, we would tag a pipe, you know, C1.1 on plan. This schedule would be, you know, on the plumbing schedule sheet. And, you know, there's only 3 columns here. I know there's, you know, some more information that would be applicable to the piping, but, you know, we're laying out, you know, C1.1, that's your domestic water piping. It's copper, type L. It needs to be, you know, certified ASTM, you know, BAE. And there's, you know, some room for adding, you know, do we expect it to be soldered or, you know, protest? You know, so we're trying to essentially see what information from the spec we can easily and should be showing on the drawings to help.
You're kind of tagging the spec on the drawing.
That's the way to look at it. Yeah.
Does this require a little bit more design capability from your contractors? So like they know which pipe they're putting in versus you could just say like drop piping.
Right.
You decide later as a designer what kind it's going to be.
So that's a great point.
Are you suggesting the engineer know what they're actually?
So
No.
like you said, this creates a culture of demanding a lot more intentionality from an engineer, which, you know, we're taking on those growing pains, but we know, you know, with this change alone, just forcing that engineer to say, I want, you know, this exactly specific pipe here, you know, throughout the design process, that's going to make them a better engineer rather than just, like you said, oh, I'm not sure what I did. I'm just going to leave all the material in the spec.
Well, that's what you're doing is you're afraid of holes.
Right.
A contractor can exploit.
Right.
You know, for
Yeah.
lack of a better term, you're afraid that's going to happen. You miss something, so I'm going to put everything that I can make a choice to ask the question.
Right. Which, like you said, can sometimes lead to, you know, bid numbers being big.
And like you said, it's unclear that what your actual intent is.
So are you saying this, like this type of schedule approach wouldn't be in
No, it's good. I'm just saying, like, from your perspective, than what you're worried about, there's, maybe I forgot something. If I start cutting it out and being more intentional with the specifications, are you worried about that?
No.
That's the answer you want, right?
No, I mean, you're basically losing your suspectors. You have your belt, you're taking the suspectors right off.
Right.
Yeah.
So there are solutions that database specs and tie it into revenue spec, master spec, as opposed to separate Word document sections. Throw them together, or look separately, or they often get a little bit. Like mentioned that there's a lot of extra stuff in there, but the solutions that do tie into Revit directly and are part of the database. I know the one thing I have used in Revit programs, it's really important because the standards are always changing, because you can update it, since you're always referencing the right things. Add the information into the Revit family is much more easier, that ties and creates an impact to those things. so it remains tied together. So, don't know that others are using it all that often, or it's still the old ways are carried forward. There are options.
Yeah, this approach too is a little more change-proof, if you will. If there's a design change, I'm going to change from cast iron to PVC or something like that. If I actually change all my cast iron piping to PVC, I mean that cast iron system line information is going to drop off. 'Cause this is reading what's actually in the model. Yeah.
It's like, this too, isn't it? Because not every 3-inch pipe is the same size. So we would potentially be changing the actual piping material and the pipe bends in the pipe as we.
Yeah. Oh, and so you can relate to how the danger landmines photograph to relate specs. So this is I'm going to play a video here, but this is a tool that we created that the technology team uses, and they essentially use it to build. It's called Plate Designer, but they essentially use it to build each specific data plate that exists on the job as they're placing it. This is voiced over, so I'll see how the volume is.
Plate Designer is one of the tools available for designing technology systems. This tool allows us to take an ordinary data symbol and add more information to it. So, for example, I can design a plate and specify the number of gangs. I can also specify the color of the plate. I'm able to add connectors to this. Now, by adding these connectors, I'm doing more than just adding an image to the plate. And I'm actually adding the product that contains a model number. These model numbers can be used to develop a bill of materials for this plate and all of the other plates on the project. I'm able to change the color of a connector and not adjust the model number. I'm also able to add structured cabling system connectors that are defined at a project level. As well, I'm able to add AV connectors that could go to a local AV system.
So essentially, the old way of placing these things was a generic symbol on plan. It was a Revit family, but it did not have, good data. So essentially what this is doing is it's associating with that specific family, in this case down to a manufacturer model number, what that exact plate is. So you can imagine, if you had done this for your entire job, we could have the ability to pull a report from our Revit model that has, the exact account, model number, et cetera, every single one of these things in the job. So I wanted to touch on point cloud integration just because we're in this kind of move data into the model category. So like I mentioned, here at KLH, we have a BLK 360 building scanner. It's not the perfect fit for every job, but it can have value. I think you'll see in this video, start it right now. Essentially, you can see kind of a somewhat complex, ductwork plan. He's going to use another tool that we made. He kind of drag a box, but it's going to quickly make a 3D isometric view of just those elements. He's going to mess around with a little bit, play with some view templates. You can kind of start to see the model there a little bit, but he's going to tweak the view template a little more. This is kind of the view that shows you the best, and he'll kind of start to rotate it around. But you can kind of see these cross-structural members here. I think he's going to rotate it some more. These guys right here, kind of coming out of the ground. You can imagine, you know, on a more traditional site survey where an engineer may be trying to like filter through like 1,000 site pictures, trying to get a good idea of what, you know, obstructions may be in this specific area. You know, these structural members kind of coming out of the ground at an angle is something that could really easily be missed. And when you're running, you know, large ductwork where alternate routings, you know, aren't just going to be coming dime a dozen, having that information when you're actively modeling can save a lot of heartburn down the line when you're, you know, trying to get that ductwork installed. Does anyone have any experience with, you know, modeling with a point cloud, you know, remodel, or beneficial, or yeah? So, the title of this slide, you know, kind of says it all. We've been talking about moving data into the model and how important that is, making it a better model. But, you know, why are we doing that overall? So, at KLH, essentially what we've done is we've mirrored the data in all of our models into a single database that we can, you know, manipulate and organize however we see necessary. So what that's doing is it's kind of maximizing on the data that exists, you know, every single one of our Revit projects. So you can imagine, you know, if you wanted to look at, you know, the last 20 hotels we did, you know, and how many PTAC units may have been on each one of those. If you don't have this data somewhere where, you know, it's searchable and you can work with it, you're not going to know the answer to those questions quickly. So I just wanted to touch on this, you know, why the data is important, you know, here at KLH for us. So the next topic, we talked about moving data into the model. We're going to go into, you know, achieving that coordinated model. I know we're all familiar with, you know, the terms flash detection software. I've never, you know, really heard anyone arguing, you know, why flash detection is important and how it can be a positive thing. You know, it's never going to be a bad thing if, you know, I find out that I drew, you know, a 10-inch storm pipe into, you know, 24-inch by 24-inch stuff. Like, knowing that that's happened is always good. The problem that I always hear with flash detection when I'm talking to architects and engineers is that, you know, the current software that is out there on the market just isn't cutting it for their workflow or for how they're set up, you know, for various reasons. You know, inefficient in the sense that it's not fully integrated, you know, into the Revit model. It's an iterative process. You know, I'm exporting models maybe into another program, seeing what the clashes are, maybe then I'm going back to Revit, you know, making some adjustments, then I'm exporting again. It's kind of an inefficient process. Licensing costs can be expensive. I know me and Eric were talking earlier, the language of the licensing and keeping up the software and stuff can be, you know, a chore in itself. It requires time investment, setting up the criteria for each and every test, what you want to see, what you want to be flagged, etc. So all these kind of pain points is, a list from KLH's experience with a couple clash detection software platforms that we had been using and had gotten used with other clients on various projects. So essentially, the solution that we decided for us is we were just going to make our own clash detection software. So I'll play this video and then I'll kind of talk over it. I think this one's quite a bit louder. Not sure why the audio is different on it, but.
All right, I'm going to demo the KLH real-time flash detection by just drawing a single duct and purposely colliding and clashing with another duct. As soon as I escape out of the command, a real-time clash viewer window will pop up and tell me that a rectangular duct is clashing with another rectangular duct. Makes sense. I can actually launch the real-time clash viewer window. These are all the clashes that are in the project, listed and organized by priority factor, which is a factor of the volume. So 1,000 cubic foot duct is going to be higher priority than a half-inch pipe. I can go through these clashes. I can assign them. I can flag them. I can accept them, and I can also put comments on here. And I can show the clash in a 3D isolate view to make it easier for me to navigate and understand what's going on.
So you can kind of see from that video how what we developed really helped touch on all the pain points we had from the out-of-box software. He essentially, drew a duct through a duct, intentionally, for the purpose of the video, but you could see a pop-up screen kind of come up here in the corner, told him right away that he drew something that would not work, in the field. And, one of the biggest things for us at KLH is, right now clash detection is kind of viewed as, really reactionary and really far down the line of the construction process, where essentially the design is getting completely done by all the engineers, all the architects, and we get the model, and then clash detection starts. Just kind of backwards from how it should be. So this tool is allowing us to be coordinated with ourselves, be coordinated with all the models that we have linked in to our models. So that was kind of our first goal, essentially get clash detection software that solved all of our issues and worked for us. So, that's great for us at KLH, obviously. But, what's the progression? What's the next thing? So the next stage of this clash viewer for us is what we're calling client clash viewer. You can see how we've very cleverly worked in KLH into the name there. But essentially what we're looking at doing is projects that we work on, being able to have our clients also have this software in their Revit platform. So we can be talking to each other directly within our models about clashes. You kind of saw that screen that popped up of all the clashes in the model, where he could, assign them to someone, comment them on someone. So you can think about how much more efficient that could be. If an architect saw this on their end, and I flagged the architect and I said, hey, I need, instead of a 2x4 wall here, I need, a 2x6 wall. And the data associated with that clash he would have, you know, the exact Revit ID of that wall. He could snap right to it. Whereas, you know, typically what we'd be doing is I, you know, send a screenshot, something like that, saying, hey, I need the wall changed 2x4 or 2x6 from 2x4. You know, we might have a couple more back and forth emails. You know, they may be making changes in their model, and like, you know, a week later we might get an updated model, and finally the wall is 2x6. So it's been working out well for us.
All right.
Kind of got some data that we've been tracking on all of our Revit models across the entire company. So essentially, when we first released this Clash Viewer, anyone in the company could use it. They could turn it on and off, and you know, kind of getting everyone to adopt it was a little bit of a struggle because it's you know, not really obtrusive to workflow, but it still is, you know, a change. So essentially, you can kind of see this manual on versus mandatory on. And this is kind of a line where that happened. So what we did is basically every new project that got set up, the Clash Viewer, you know, the live Clash Viewer was turned on, and every user had to make a conscious, you know, decision to turn it off. So you can kind of see over time, this orange graph is kind of representing all the clashing elements within the model, and the gray is, you know, the total elements that are not clashing within the model. You know, ideally we'd like to see these, you know, numbers grow away from each other to where, you know, ideally this would be 0, but you can kind of see how that trend is starting to happen for us. So it's been pretty cool to see. This tool is another one that we made. I thought I'd put it in here just because, you know, we've been talking about Clash Viewer and modeling more, and it's relatable to visibility. But the name's kind of self-explanatory, but the text of this screen we're all probably used to. You know, it says none of the created elements are visible in yada blah 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 floor plan. So I'm sure, you know, everyone knows the pain point of drafting something in a view, and that screen pops up down here and you can't see it, and you don't know why, and there's, you know, 15 different reasons why it may not be showing up. We actually found, you know, throughout the company, a lot of people were spending a lot of time trying to figure out why they couldn't see something. So we knew we had to do something about it. So I'll play this video. It doesn't have sound, so I'll kind of walk or talk through it as it plays. But essentially, this is an HVAC plan, and you know, we can't see the lighting fixtures, which would be important if we're placing, you know, like a ceiling cassette or something like that. We don't want to place a light and a ceiling cassette in the same spot. So he revealed all hidden elements, clicked on what we want to see. We want to see the light, right? After we did that, this is a list of all the views in the model. We're going to search for the view that we can't see it in. We're going to select it. We're going to run the tool, and I'll try to get this stopped so you can see it. Yeah, I think it's stopped. So it says element is hidden because light fixtures category turned off in visibility graphics. So I know if I go to my view template, hopefully I have one applied. If I don't, I just go to my visibility graphics, go to model categories, turn the light fixtures on. I'll be able to see it. This list, you know, like I said before, could be 6 items long. I know when I first started out, like this was the most frustrating thing to me about Revit was not knowing why I couldn't see something. So it's been a great tool and a time saver for a lot of people. All right, so the third category I'm going to talk about, improved visualization to the field. This essentially requires the two previous items that I've been talking about, which is proper clash detection and having as much data within the model as possible. That's what's going to make using these items possible. So first item I'm going to talk about is QR codes. I know we're all familiar with QR codes. They're pretty much everywhere these days across any market, industry, etc. You scan them on your phone. Pretty much any smartphone has, most of the time we'll just do it automatically if you open up your camera and scan it, or through an app. And it'll take you somewhere for, more information or advertising for whatever it's for. But these are actually very good for helping show intent on the plans themselves. So the example down here is of a mechanical room, and it's kind of enlarged here, but we got 3 fan coil units here with a lot of ductwork that's in plan view. You can imagine without having either of these two images here, it could be very challenging for the contractor to know how I wanted that ductwork routed. And it could very easily result in them routing it in a completely different way that may or may not interfere with the surrounding trades, which would obviously create other headaches, RFIs, rework, etc. So you can imagine the contractor, even on the job site, because every contract worker or site foreman, etc., they've all got their phone in their pocket, pretty much always have it with us. They could see this plan, they could pull it out, they could scan this, and they'd be able to essentially kind of spin this 3D model around, see how the ductwork was intended to be routed, and improve visualization in a really, really good way. Has anyone seen any QR codes yet popping up on plans at all?
You're saying instead of putting a detail page, you're essentially putting a QR code with a usable 360 kind of access to the model.
Yeah.
And just a smartphone will pick up from the camera.
Yeah.
They don't need any other.
Yeah, they don't need like a HoloLens or any of this, kind of VR stuff. We will usually accompany it with, maybe an isometric, but we only get one view, or we only get one angle, maybe the southwest.
You said that they might install it a completely different way off of the 2D. Do you have any issues with kind of getting into means and methods a little bit?
Yeah, it's a valid question. I think that kind of goes back to what we were talking about earlier, where it's kind of requiring the engineer to actually figure it out.
It's a lot more work for you.
Right.
It is. And
Yeah.
You're hoping to give more information to the guys in the field.
Yeah.
But at the same sense, you're kind of taking away their creativity to do it themselves. I'm trying to think of a way to explain it, but
Yeah.
it's different, right?
Yeah, I see what you're getting at. I know a lot of contractors, for whatever it may be, they have like a very specific way of doing something. And if, a drawing tries to make them do it another way, it can actually be, more expensive for them.
Right. You have an offset in there. They might say, well, I didn't plan on that offset. I was going to go straight up. It's actually more efficient. It's taking that out of it.
Right.
But now you're telling me I have to use this. I don't know. I'm not sure what my question is. I'm just saying,
Yeah.
do you have any issues with that?
I don't think we've run into that yet.
I was just gonna say, I've been in the room in a handful of conversations where we've done this this type of thing. And the way that conversation tends to go instead is that this much more clearly illustrates our intent, and it allows us and the contractor to have a more informed decision with each other, instead of, it doesn't turn into like, this is exactly how I want it. It becomes, you can clearly see the intent, and so we can have a conversation that is based more on knowledge and less on what we think the other person is saying.
I think that really gets to your point where drawings for permit are different than drawings needed for construction.
Yeah.
And by not having 20 different isometric views or perspective or whatever, you've condensed it down to a plan detail that shows some of the intent. You have a large detail, and then you have a single image. But at the same time, you're helping the contractor out with a rotatable 3D thing that you can see, examine, and identify. And certainly, from our standpoint, if you had a better way, you're certainly welcome to suggest it, and we might be able to agree on the same thing, same resolution.
So just to close the loop, what you're saying with this, your intent, not to say you have to build it like this, but we made it work like this. This is the way we see it. If you can pick up a better way, you have the right to do that as a contractor, as a builder.
Yeah, I would agree with that.
Here's our intent. It's subject to change.
Roots constructability.
There you go. Yeah. Roots
Yeah.
constructability.
That's
All
my
it costs
experience.
me more money.
My experience.
Him specifically.
Well, I think that what he's showing is this is already coordinated with all the other trades. So at that point, you have something that's got no clash with structural architecture, all the other trades that are in there already, whether it's technology or somebody else already is in there. So when they come in as a contractor, at the time they come in, not everything is there. Granted, structure should be there. I would hope, but there's other things that that wouldn't be there possibly. And so this is one way of showing this works. So then at that point they would do a twist on that. They would also have to consider, I think, the other trades again and make sure that whatever they're changing would have a similar result to what that is. And so I think it kind of illustrates this is what we intended to do with all the other trades together. This is what we came up with. And if you guys want to change that, you can. You just have to make sure that your end result is as coordinated as that is. I think that's how I would take it.
Yeah. I like
As
that.
a-
Go ahead, John.
As a mechanical engineer, oftentimes at the beginning of a project, I'm working with an architect and they're asking me, how big do your mechanical rooms? I tell them the size and they say, that's great, I'll give you half. So this is what allows us to be able to do that with any level of confidence. You're like, yeah, we can actually fit everything we need to fit in this room. And the end user, performance systems.
Can I ask you a question about your in-house kind of clash that you're using?
Yeah, sure.
Because, we don't typically clash for walls because we're going to get clashes all day long.
Yeah.
You said like a drop in there, 5 and 4 inch wall is going to come up. Does your system see that separate as just a penetration through a wall, or do you get like a red flag and say, I have to okay this or not okay this?
Yeah, so we have, so two-part answer. Any clash can be ignored or essentially said, like, this is fine, don't worry about it, and it'll never bother you about it again. But we also have a really good ability to sort, filter that huge list of clashes, so we don't have to deal with them. So I could say pipes and walls, like I don't care. And then the user they'll have to kind of say that once, and then you won't have to deal with that throughout the whole project. That kind of answer your question.
Yeah, and so
We've also taken it a step further recently, read an algorithm that pipe is going perpendicular through a wall, doesn't count it. It's running like parallel to the wall, like you're shaving across the side of the wall, you're going diagonally through the wall.
Yeah, that makes sense.
Because you're working.
Unfortunately, I have to leave here soon, but I have a question that I want to make sure I get asked. Roughly 10% of your staff are programmers. How are you finding them and training them to be engineering specific or architecture specific or discipline specific to solve the problems that you're coming into?
Yeah, great question. It was actually really cool when we kind of started on this Revit journey, like, 2 years ago or so, and programming, really started to pick up. We actually found there were a lot of engineers that were already employed that knew programming to a certain degree. Maybe they were a hobby programmer, and what really worked for us was giving them the place or the time, during business hours to kind of flex the programming part of their brain and actually be able to do it. We've actually also started having full-time software programming co-ops as part of our co-op rotation. Who would have gone into programming not knowing that they ever would have been into the construction industry, but they end up at KLH.
Thank you for that.
Yeah.
Hope to see everybody next time.
Let's say I work for an engineering firm that's not KLH. How can I benefit from these tools?
That's a fair question. If you're right, you could do that. If you're an engineering firm that it's a project that has multiple firms on it. It's something that we would be willing to share with the project team in a controlled way. It wouldn't be like, but not you, you're a consultant, right? Also does the same stuff we do. But obviously there is some, competitive edge, if you will, that this gives us that we, put the work in to acquire. So, yeah.
Who else in it? Oh, yeah. Okay. So, how are they each have you here? Totally big. It's not my tech. It's not rocket science. We use the Revit API to do all this. All this stuff new, wild thing that doesn't exist out in the world to make this happen. So, hopefully, we don't show this off just because of, hey, we want to show this off, hopefully, motivate others to take the same steps, cut out the waste, the API to your advantage. All this can be done. So, that's the full answer to your question. You can come work for us.
So like clash protection in there, right? There's a clash protection tool, there's glue, there's things like that that people can use. You're just a customized version, right? That's the difference. There's tools out there, we just customize them to be more efficient. That's really different.
And made them a little better.
Are you guys looking at, I have an electric panel that needs X amount of clearance in front of it and not have water lines over top of it, or
Yeah.
I need to get access to a VAV box or a filter, or I need to figure out how to get a motor out of a particular unit for service, or are you addressing those?
Yeah, so we've done a lot of work in creating families that we use within our model, and where it's applicable, we've modeled basically clearance zones that are, kind of they're voids, they're not solid, but our clash detection software will tell us if a pipe is running through the front clearance of, an electric panel. So yeah, we've thought about that, incorporated ways to address it.
I'm assuming it's picking up other models as well, right?
What's that?
So whatever models you have linked in, it
Yes.
will pick up all of that information.
Yeah.
I've used this software where we were doing the MEP services and someone else was doing the fueling. And so we were able to have that conversation with those other engineers to be able to say like, hey, can you move it? And sometimes it's not, if we didn't have that, we'd say like, hey, I need you to move like 2 feet. And it's like, is it really 2 feet, or like what, if it's really 1 foot 2 or 8 inches, and it gives you kind of more information and a better conversation. And then any clash detection software would do that. And if people don't know programming, I feel like for an engineer, it'd be easier to pick up families. And that's definitely something you can do at clearance. Clearances to your families, where you know clearances around an RTU or a VED or VAD box where that exists. Just model it.
I know we're starting to run over a little bit here, so I'll try to hit these last couple points quickly. So kind of I get what I would call like the next step up from QR codes. Probably a little less accessible in the field. I'd probably like to have at least like a tablet size screen to be able to work with this. But it's essentially a portion of your Revit model that you've kind of predefined and exported as a 3D PDF. We use Bluebeam here at KLH, so they have a 3D PDF add-in that you can put into Revit and export 3D PDFs. Got one just real quick here. Show you real quickly kind of the power that it has. So, we have the QR code here that would kind of give you some insight into this room, but if you were in a client meeting or something, talking with some contractors, this screen up here is actually, fully interactive, model of that space. Also, I can click on, elements that are in here. I don't have the properties window up, but you can actually see, all the parameters, of that item and what those values are. You can cut sections, slide, kind of see, if what the view was set up doesn't give you exactly what you want. So there's some increased functionality there that could be beneficial. You might want to look into also.
You're linking to Bluebeam?
Is that?
You're linking to Bluebeam?
Probably
Bluebeam?
It's
the PDF is embedded in the drawing file.
But I don't think you need to see it, do you? Use a normal PDF to do it.
I believe you can see them in Adobe also. It might not have 100% of functionality within Bluebeam, but yeah.
I think we do have a reviewer too.
Yeah, the reviewer will let you see the PDF. You can't make any changes, but you should. Make any changes to it. But the reviewer will let you spin it around, check all the properties. I use full model 3D PDFs of the structure to send out to people again.
Yeah.
This is what we're thinking of for beams and columns. It's a nice thing to look at on a screen like this instead of looking at the Revit model, waiting for it to render.
Yeah.
Every time they twist.
Yeah, exactly. So that was 3D PDFs. So real quick, kind of circling back, to the data, I talked about having a database where, all the data from all the models across our company kind of lives. There's kind of unlimited potential that you could do with all that data. Example I like to give is if, an engineer comes across a room that they've never designed before, maybe it's like a kiln room in a high school or something. The old way of figuring out, what needs to be done, maybe, asking the guy next to you, maybe he's done it, maybe he hasn't, maybe it's the third guy you ask, and, they're trying to remember what the project was, etc. But, as an example, if you had this database, you wanted to look, at every kiln room that your entire company has ever designed, the elements, etc., that they've lived, within that room, that's just an example of how this, this data can be used. So, if you haven't been able to tell from this presentation, obviously here at KLH, we've completely committed to Revit and what power of it is and what it's capable of. I talk about all the tools that we have. I'm sure some of these Revit toolbars look familiar, but
You know, at this stage, we pretty much created our own tabs where all of our own tools live that are accessible to all of our designers. These are some pictures from, you know, the general tab, but we've had to move to discipline-specific tabs just because we have so many at this point. I think I was counting trainings on our intranet. Today we've got like 70 trainings for tools that we've developed, so it's really taken off since we started making them. So last slide here. I know I've covered a lot, talked about, you know, a lot of tools that we've developed, as you touched on. You know, you can't go back to work tomorrow and kind of have them in front of you. So, you know, what's my call to action here to, you know, everyone? You kind of read these questions to yourself, but I think, you know, answering all of these and acting on them is setting you on a path towards, you know, having a better BIM model. You know, whether it's, you know, just looking at one thing, maybe one detail, you know, that you're using right now, that's just generic lines. Like, just think about, okay, how can I just do this one detail better, fully model it, you know, see how that process is, learn from it, you know, talk with your peers, etc., and just kind of keep the ball rolling from there. So that's all I had for everybody. You know, any last questions, comments? No?
I want to add something real quick.
Yeah.
I think you touched on a lot of good stuff, the methods part, and then the work for a community engineer. And the great thing about the user group, we want that Cincinnati. That's that collectively as a community, kind of share this stuff, leverage each other. You know, Mark, was it? Mike, we were talking about us. Now we can get all this patch public. I wish we could make all our tools public, but there's that like whole, like, you know, if you're so far ahead of the group, kind of need, you know, there's somebody that's ahead of us. How do we just collectively come together and take advantage of them, data, and all that stuff.
All right, well, I want to thank, you know, everybody for coming. I hope to see, you know, everybody at the next one. I already had to leave. Thanks, hosting the next one, and that's involved, so it should be a good one. Thanks. Thank you.